Okay, happy Friday, pre-calc. Mr. Pashar here. This will be the last video on solving log equations. I'm going to show you today, first we'll do a review problem, and I'll show you today how do we handle a log equation that has logs on both sides. And then I'm going to have one more video for you today, a short one on how do we handle solving exponential equations that are a little bit more difficult, where we have to use something called substitution. We typically see that thing happen in calculus when we have to do problems, but I'll show you how we handle it here. There's a few exercises in your textbook that require that skill. The book does give an example or two, but you know how the textbooks are. It's hard to follow them sometimes. So let's review with this one. We seen something like this yesterday, and you've seen plenty of these in the exercise set in your text. We have something like log base 2 of x plus 2 minus log base 2 of x minus 5 equals 3. So if you remember from your lecture notes and the reading that I hope you did, some of you are probably rolling your eyes, of course, but when this situation happens, we have to go ahead and condense these two logs into one. So we have the same base, that's good. This is subtraction, so that means it comes from division. So as one log, I'm going to write this as log base 2 of x plus 2 over x minus 5, and that equals 3. So we condensed it to one log, and that's what we wanted to do. Our next step, of course, is, well, how do we lift the argument out of here? Well, this is a base 2 log, so that means we raise up both sides by base 2. So that means we have 2 raised to the log base 2 of x plus 2 over x minus 5 equals 2 to the 3 power. And this is exactly what we want to do, because now this property lets us to erase these, and all we have left is the exponent here, the argument, x2 over x minus 5, and that equals 8. Because on a normal day, 2 to the 3rd power is 8. So now this isn't too hard to solve. I'll come over here, multiply here. So that's going to be 8 times x minus 5. That will give you 8x minus 40 equals that x plus 2. Okay, so we have this. Now this is easy to solve. I'll bring x over, so I'll subtract it over. That gives me 7x minus 40 equals 2. Go ahead and add the 40. 7x is 42. Divide by 7 gives us 6. So this one wasn't too bad. Now, do you remember what I told you yesterday? I hope you did. The fact that when we solve log equations, we do need to check to see if the solution does work, because sometimes we do get extraneous roots, meaning that they don't work. So if we plug this back in here, you'll see that log 2, this is 6 plus 2, which is 8. Log 2 of 8 is 3. So keep that in mind, we have a 3. And if we plug 6 in here, 6 minus 5 is 1. Log base 2 of 1 is going to be 0. 3 minus 0 is 3, so we know that this guy is correct. So the solution set for this equation would be a set of 6. These are pretty tame. These aren't too bad. Now, sometimes the textbook does tricky things. They'll put a power up here, but you know better than that. That power just slides down in the front, right? So it's nothing new. So this would be a good time to pause the video if you need to go back and redo this problem. And I'll step out for just a moment. Okay, welcome back. So let's look at another situation that develops. What happens if we have a log on both sides of the equal sign? Because that does happen to us. So here's an example of something that could happen. This is example 2a from your lecture notes. We have log of x equals log of x plus 3 minus log of x minus 1. So what you notice now this time is we have logs on both sides of the equation, and that poses a problem for us. But there is some hope. We have this nifty property that says if we have log base b of u, and that's equal to log base b of v, then u equals v. So it's a lot of garbage, right? But what does that mean? It means if we could get both sides condensed and have the same base for the logs, all we have to do is set equal their arguments. Just like the thing with the exponents. Remember we had, if we have b to the u equals b to the v, that implies u equals v, we set the exponents equal. Same thing happens here with the logs. Same base logs, we just take their guts essentially and set them equal. That's our game plan here. So watch how simple this becomes then. It's really not all that difficult. Can't condense this guy, so I'm just going to rewrite it. Log of x. We'll condense this. So this is subtraction, so that means we're going to divide them. That means we got log of x plus 3 over x minus 1. And the property says if we have the same base logs, remember this is a base 10 logarithm because we don't write the 10, we just assume it's there. We set x equal to x plus 3 over x minus 1, and there you go. So all the log garbage is gone, you're just left with this equation here. Pretty nifty, huh? I think so anyway. So we'll go ahead, we'll cross multiply. This gives you x squared minus x equals x plus 3. Now obviously this is an x squared, so this means we're going to have a quadratic equation, so that means we want to get all of this stuff over to the left. X squared minus 2x minus 3 equals 0. Remember, you have 3 ways you can solve this. You guys all hate factoring, but that's where you want to start. And I think we could easily factor this guy out. X and x. Factors of 3, well, not much choice. 3 and 1 if we're going to attempt it. How are we going to get minus 2? Well, it's going to work. We just have to pick the right sign. This will be minus, that'll be plus. Again, you should know why at this point. If this middle term is negative, we have to have the bigger of these two numbers hold on to the negative to give us that negative in the middle. We'll set both factors equal to 0. So what is this going to give us? This is going to give us x equals 3 from this guy, and x equals negative 1 from that guy. Now we just have to go back and check, see do these work. So if you plug 3 in, 3 and 3 is 6, you have log base 10 of 6 minus, this is going to be log base 10 of 2. Now if you get your calculator and you compare these, it will give you this log value over here. So I'll leave the check to you. This one here will be a problem. X equals negative 1. Because if you plug in right away negative 1 in for this x, remember logs can't take on negative numbers, so we have to throw that one out right away. So the solution here is just 3. So you get 2 answers, but you only end up keeping 1 because the other one is extraneous. Okay? So that's how you do something like this. You condense both sides. This one's already condensed. If they have the same base, you go ahead and just set their guts equal to each other and you solve like normal. Use all the tools from Algebra 1 and Algebra 2. Again, if anybody has any questions, please feel free to call between 11 and 1, email between 11 and 1, and I'll get back to you on how to do this, but I think this example will help you, and you have plenty of examples in your lecture notes. So stay tuned, I will upload this one today, and also stay tuned for the last video of the segment, which will be solving exponential equations that require something called substitution. So until next time, take care, stay healthy, stay safe.